And may I request all the speakers to come up here, and now we're going to go through a mix of questions addressed to various speakers, some which were raised even earlier and are pending, and some new questions which are coming in, and you can still send in more questions. Here's the coordinates up here. So maybe just going in, not in strict order, but one of the older questions which was left unanswered. I think I did not ask this question. This was for Ajit. So this is a question from an anonymous poster. Does time stop within a black hole?
So one has to be careful about what we mean by time. So according to Einstein's theory, time is not absolute. There is nothing called time, nothing called space. But each local observer can measure their time according to the local clocks. But so what I meant earlier was that if there is someone with a clock and the horizon of a black hole, and they broadcast the time that is measured by the local clock, then someone sitting outside, very, very far away from the black hole, would see that the time has stopped. But as far as that person is concerned, the time runs fine. So it's very difficult to imagine, but it just means that there is no absolute time. So the statement is that the time at the surface of the black hole, as seen by an observer, stops.
Okay. There's one more question again for Ajit. It's from Vijay Raghav, who's a class 8 student, who asks, how does the Pauli exclusion principle prevent small stars like the sun from collapsing into black holes?
Oh, very good one. Yeah, it's a very sophisticated question. So basically, the Pauli exclusion principle tells you that no certain types of fundamental particles like electrons, neutrons, protons, etc., they are called fermions. So no two particles can accumulate the same sort of position in the phase space. So they cannot have occupy the same space in some abstract space, not only in space but also in energy levels. So if you compress these atoms to very high densities, then they form a lattice of crystal with some free electrons. And when you compress these ones, then these electrons are forced to occupy the same space, which is not allowed by some fundamental principle of physics. So this allows these particles to exert some pressure on each other, which prevents them from which prevents against the gravitational collapse. So that's why, for example, these white dwarfs are sustained against gravitational collapse. This is called the electron degeneracy pressure. In the case of neutron stars, it is the Pauli exclusion principle applied to neutrons.
Okay, thank you. I'm looking through a big list of questions. So I think this is a question. Yeah, this is a question from Mitali from Arvind. It was posted on Twitter. Has the Ayurvedic system been through the modern system of testing double-blind with control groups, etc., like the allopathic system, which is evidence-based? And I guess you did touch upon this already in your talk to quite some extent, but if you have anything more to add to this.
No, I think they are fundamentally different ways. So I think testing them through the modern method meaning modern medicine kind of method will not be appropriate. So that is what I keep on telling a lot of people, that if there are two different approaches, then you have to evolve an approach which is not that if it is not like modern medicine, then it is not true. So we need to think through these.
Thank you. Okay, I can't find, I thought there was one more question, but I can't find it right away. I can find a question for Hema, because it is right at the bottom of this feed. Can the machine learning paradigm evolve to identify the exact structure of the instrument by listening to its sound from a distance?
Structure of the instrument means what? I mean, I don't understand it. Is it like getting the shape of the violin from listening to the violin? I mean, what I played, for example, what was it? It was not flute. Most people think it's flute when we synthesized. It was not the flute. It was simply a sinusoidal modeling algorithm which generated the sound back. Okay, so I don't know whether you can get the structure of the instrument from the, very difficult, I think so.
Okay. So there's been a lot of discussion about machine learning in various talks, and this question was raised by Vignesh, I think immediately after Siddharth's talk, but maybe everybody has some comments to make on this. It's a very open-ended question. With such intelligent computers that automate mental processes, don't you think that artificial intelligence will overpower humans and rule the world? Like some, like some Hollywood movies and the warnings by Stephen Hawking. So what are your views on this?
No, it doesn't have
that's a
motives.
very short answer, but we'd like a long
Okay.
answer.
It doesn't have motives. The danger, if you want to think of dangers, is some humans powered by artificial intelligence ruling other humans. If you want to talk about real dangers, yeah, which I won't talk about at length, but yeah, artificial intelligence is a tool. The only danger of tools is that they can get wielded by some. That's
Yes. So this matches what a recent Turing Award, not recent, but a decade-old Turing Award winner, Vint Cerf, also when he was asked a question very similar to this, he said, I don't think we should be fearing the AI, we should be fearing the humans who are using the AI. Yeah. Okay, I
just want to add to that. It actually only finds patterns in data. It does not look at the, what the pattern means. I don't think it even knows that. You ask ChatGPT this question when it gives you an answer. Do you understand what you're saying? It'll clearly tell you, no, I'm not understanding, I'm just finding patterns. That's exactly what it does. I mean, ChatGPT, which is a huge, large language model.
I see one more question for Ajit, which was raised quite some time ago and I had not noticed it. It's from an anonymous poster. Can the formation of a black hole through collapse of a star create a wormhole?
No.
I do not know what is a
No,
wormhole.
no. Wormhole and black holes are both mathematical solutions to Einstein's equations. Wormholes are, in some sense, you can create some connection between two regions in space-time. That's the attraction to wormholes, that lot of unravel, lot of imagination, time travel, etc. But it turns out that, according to our current understanding, to create a wormhole requires the violation of certain basic principles of physics. And most people don't believe that would happen. So most people, physicists, believe that wormholes cannot exist in the real universe.
Thank you very much. So I think I have reached the end of the questions here. And in case any of you still have questions later on, maybe you can try and meet the speakers and ask them. For now, please join me in thanking all the speakers here. So we've had a very nice set of talks touching physics, molecular biology, automated mathematics, music and signal processing. And this is what the Science at the Sabha aims to do, to convey some excitement at what current research is doing. And we hope that we will be back here next year with a similar event, and we hope to see all of you here again. Thank you.